The position of a puck G is recorded as shown in document 1. In the space reference taken here considered, we have the x-axis of origin O. G0 is the initial position of the puck. G1, G2, G3, G4, G5 are successive positions that are separated by a time equals tau and by a distance equals capital T. So look carefully at document 1 and answer the following questions. Question 1. Compare G0, G1, G1, G2, G2, G3, G3, G4, and G4, G5. See if these are the distances. G0, G1, G1, G2, G2, G3, G3, G4, G4, G5. So though we are not given the values here, we are given that they are equal to a distance D. So they are all equal to each other, which is equal to D. Conclusion. The distance traveled during equal intervals of time are equal in this case. Calculate V01, V25, V05. When I have the index of the speed with two numbers, this means that this is average speed, even though we did not mention it. So this means that we have to calculate the average speed between instant t0 and t1. T0 and t1, the distance is capital T and the time is tau. So V01 equals G0 G1 over tau, D over tau, unit of speed, because we have to mention it here, though we are not given values, but you have to mention that finally we have to get a unit of speed. V25 is the average speed between instant T2 and T5, which is equal to G2 G5 over 3 tau, equal 3D over 3 tau equals D over tau. And V05 is the average speed between T0 and T5 is equal to G0 G5 over 5 tau, which is equal to 5D over tau. 5 tau equals D over tau, unit of speed, of course, all of them. So what can we conclude here, or what do we notice here? That the average speed is the same between any two instants. So if we consider any two instants during the motion and we calculate the average speed, we found it to be equal to the other one. Calculate the instantaneous speeds v1, v3, v4, even though if we did not mention instantaneous speed and we only said that speeds v1 because the index here constitutes only one number, this means at one instant. So at instant t1, at instant t3, and at instant t4. v1, we have to take before and after. So G0, G2 over 2 tau, 2D over 2 tau, D over tau, unit of speed. Similarly for V2, before and after, though it's not required to calculate here, but you're going to see later on that we are going to use it in the second part. So if you only answer by V1, V3, and V4 for this question, it is correct. Then later on, when you use V2, you can calculate it. The conclusion here, as you can see, is that the instantaneous speed is constant, so V1 equals V2 equals V3 equals V4, and moreover, it is equal to the average speeds that we calculated before. Now concerning the acceleration, calculate the accelerations A2 and A3. So we have now to use V3 minus V1 before and after over 2 tau. Because they are equal to each other, V3 is equal to V1, D over tau minus D over tau is 0, so the acceleration is 0, unit of acceleration. A3 is equal to V4 minus V2. So V4 was calculated here, but if you did not calculate it here, and this is normal, you have to know that you have to calculate it in this part, in question 4. So V4 minus V2 is going to be equal to 0 because they are equal. There is no change in the speed. This means that the acceleration is 0. So what do you notice? The acceleration is 0 at any instant. So these are the 4 characteristics for a uniform rectilinear motion. Distance covered during equal intervals of time are equal. Average speeds during all intervals of time are equal. Instantaneous speeds are all equal to each other and are equal to the average speed. And the acceleration is 0 at any instant.